Okay, hello, welcome to my channel. My name is Loange, and in this video, we're going to find the square roots of these two complex numbers, alright? So we're going to find the square root of this one and then the square root of this one. Good. So we're just going to start off with the first one, but then I'll tell you, we are going to use two different methods, okay? The second one is going to be a little bit tricky. Good. So let's see. We want to find the square root of 15 plus 8i. Good. Now, we should take note that the square root of a complex number will give us a complex number. So what I'll do here is to equate this to a complex number. Say the square root of this will give us some sort of complex number, which I will say p plus qi, where p and q are real numbers, all right? That's just what we make for p and q. They're just real numbers. And when you join the q with I here, then we have the complex number, where p is the real part and then q is the imaginary part. Good. Okay, so our aim here is to find p and q such that the square root of this will give us that, all right? And then we are done because we want to find the square root of this, which will also be a complex number. And you know that every real number is a complex number. So from here, the first thing we'll do is to take the square of both sides. So when we square both sides, that is, you square the left hand side, okay, and then you square the right hand side. Of course, 2 will cancel out with the square root, and then we're going to have 15, okay, plus 8i. To be the same thing as well, we're going to square this right hand side. So using the binomial theorem of expansion to the power 2, we're going to have p squared, okay? Then when we square qi squared, we're going to get negative q. The negative is from the fact that I squared is negative 1, right? Negative q squared. And then we're going to multiply p and q and I with the 2. We're going to have plus 2i pq. Good. Okay, so the quality of two complex numbers, we know that when two complex numbers are equal, it means that their real parts are equal and then their imaginary parts are equal. Good. So in that case, we're going to say 15 is the same thing as the real part, which is p minus qi. The real part of a complex number is the part independent of the I, right? So there's going to be 15 equals to p squared minus q squared. Then the imaginary parts are also equal. So 8 will be equal to 2pq. The imaginary part is the coefficient of the I. Good. So you're going to have 8 equals to 2pq. Okay, great. So you notice that maybe we can call this equation 1 and then call this equation 2. So from equation 2, you see that we can also have pq to be equal to 4, right, by dividing both sides by 2. Good. So this is what I'll do from equation 1. From equation 1, let's make p squared the subject. Okay. When we do that, we can see what we get from there. So you see, notice that from equation 1, p squared will become, we add q squared to both sides. That will be 15 plus q squared. Good. So from here, we can substitute, maybe take the square of this. We can substitute this for p squared in the second equation. So from the second equation, we can also have that from equation 2. We can also have that, well, p squared q squared q squared will be the same thing as 4 squared, which is going to be 16, all right? And that is so because if you divide both sides by 2, you're going to have 4 equals to pq. You take the square of both sides, all right? That will become p squared q squared equals to 4 squared on the left hand side, which is going to be 16 right here. Good. So you're going to substitute the expression for p, and that will be, maybe let's call this equation 3, and then let's call this equation 4. So we say substitute the expression for p, which is p squared equals to 15 plus q squared into, substitute it into equation 4. Good. So when we do that, we're going to have equation 4 will become, in place of p squared, you're going to put 15 plus q squared. So that will be, so let me mark it from here. All right, 15 plus q squared, that is in place of p squared. So let me show you what I mean. So in place of p squared, we're going to put 15 plus q squared. So this is 15 plus q squared, right? And then we have the q outside. Then the q squared is here. And then we equate it to 16 on the right hand side. Good. So that's what equation 2 will become. Substituting 15 plus q squared in place of p squared. So we're going to open up the bracket, right? That will give us q to the 4th power. Q to the 4th power, then plus 15 q squared. And then this is 16. And then we subtract 16 from both sides. Minus 16 equated to 0. here we have, we can rewrite this as a quadratic in terms of q squared. All right, this is q to the 4th power, q squared, and then q to the 0 power. So if you reduce this to q squared and square of that, you notice it's going to become a quadratic in terms of q squared. And we can use the factorization method to do this. We think about two factors. We product as negative 16, and then we sum as, this is supposed to be 15. All right? This is 15q squared, yeah. So we product as negative 16, and then we sum as 15, all right? So two factors are, let's say, 16 and negative 1. When you multiply 16 with negative 1, we'll get negative 16. When we add 16 to negative 1, we'll get positive 15. Good. By that means that q squared, we can easily get q squared to be, well, since this coefficient here is just 1, and we've gotten the two factors, when you do your factorization method for a quadratic in terms of q squared, we'll get q squared to be 1, or q squared is negative 16. Good. So from here we can get q to be, well, q squared is 1. That means q can be positive or negative 1, all right? Because if you square any of this, you'll get 1 as your right hand side. But look at this. Q squared is going to be a negative 16. That means q will be a complex number, because we cannot square a real number and get a negative result. But remember what I said when I equated this to p plus qi, said that where p and qi are real numbers, all right? So q giving us the square of q giving us a negative result means that q is not a real number. So in fact, this is not a solution, all right? So we can cancel this right here. These are the only solutions that we have. Good. So we are going to solve for the value or values of p, given that q is positive or negative 1. And we're going to use this equation to do that. Okay, that is from equation 3. So we substitute q equals to that. So you put in, substitute the values of q. We're going to substitute the values of q, which is positive or negative 1, into equation 3 to solve for p. And when we do that, we're going to have, well, p squared will be 15 plus, we start off with plus 1, so that we see what we get, 1 squared, all right? Well, 1 squared is 1, and then this is going to be 16. And then the square root of 16 is positive or negative 4. So p will be positive or negative 4. All right? Like, square root of 16 is 4, but solving for the value of p that will satisfy that equation, we'll get positive or negative 4. That is when q is negative 1. So you're going to take when q is, well, that's when q is 1. Now, when q is negative 1, observe that this is a square. All right, so we are going to get, in fact, the same thing, because the square there will make 1 and negative 1 to have the same result. So we substitute negative 1 for q, and then we square that. This is going to be 15 plus 1 as well, which is 16. And then we take the square root of both sides, we'll get the same thing. So what that means is that when q is 1, we'll get positive or negative 4. When q is negative 1, also get positive or negative 4 for p. In fact, the result has this form. The result will be of this form. You get p, which you can say positive or negative 4. Okay? And then q has positive or negative 1 as its sign, or negative 1. And then we multiply with the I. Good. We can factor out the positive or the negative signs. And then we're going to have positive or negative 4. Okay? And then into 1, that is positive or negative 4 plus 1i, of course, that's just I. Good. So this right here is the square root of that complex number. Okay, so that is how we can use algebra. I know we are going to use some other methods as we proceed in the course, where we're going to convert this to a polar coordinate and then see where we can go from there. But this is a very interesting one. So positive 4 plus I, or negative 4 plus I, when you square that, you're going to get 15 plus 8i. So this is the square root of that. Good. Okay, so let's go over to the second one real quick. Okay, so after solving the first one, we put the answer this way. You know, when you take the square root of both sides, of course, we expect to have that. Good. Okay, over here, we want to take the square root of this complex number. And like I said, we're going to do a little bit of a trick here. All right? Okay, so let's see. Well, as before, we are going to equate this to a complex number. I said that the square root of a complex number will give us a complex number. So we say p plus qi. Good. Where p and q are real numbers. And of course, I is the square root of negative 1. So let's see what we do. Well, as always, we're going to take the square of both sides. So So when you square the left hand side, you square this, we're going to have 8 minus 6i, then you equate it to the square of the right hand side. So we square the right hand side, right, which is p plus qi. Okay, great. Then the next thing is to expand the right hand side. So this is going to be, well, when we expand this as before, we're going to get p squared, then minus q squared, and this negative is from the fact that I squared is -1, and then we're going to add 2i pq. Good. That is from the binomial theorem of expansion. Then we notice that let me put the left hand side this way, that is equality, that if two complex numbers are equal, it means that the real parts are the same and then the imaginary parts are the same. So we're going to equate 8 to p squared minus q squared, and then we're going to equate -6i to sorry, let's forget about the I. Let's take only the imaginary part, right? We equate it to 2pq. Good. Maybe let's call this equation 1, and then let's call this equation 2. Okay, so you observe that from equation 2, p times q is going to be, from equation 2, right? P times q is going to be -3. P times q is going to be -3. That is by dividing both sides of equation 2 by 2, sorry. Good. Now observe that the product of these two real numbers gives us -3. So here is where the trick is, all right? If the product of two real numbers gives us -3, we can think of real numbers which when we multiply you get -3, and not to really go on and on forever. We only think about whole numbers which when we multiply we get -3 as an answer. Okay, so the trick here only works when p and q are going to be whole numbers. Otherwise it may not be useful, because thinking about infinitely many fractions which you can multiply to get this is not really that's, you know, this is an equation with more than one unknown. So yeah, it's not going to give you, it's going to give you infinitely many possibilities. But thinking about only whole numbers that will make this work, it can be a great trick. And of course, let's check. So let's think about two numbers which when you multiply you get -3. So let's see, we may need more than this. You notice that you multiply -1 with 3, you get a -3, all right? And you multiply 1 with -3, you can also get -3. Good. So I think that's all. Those are the integers that we can get. This time that will give us -3, this time that will give us -3. And since p and q are just arbitrary whole numbers, we are going to test for each of them. Maybe we can say let p be -1 and let q be 3, and then we check if when we square this expression, given that p is -1 and q is 3, if we'll get this as the result. If not, maybe we can switch. Okay, so let's see what we get. So we say so we start off with p being -1, let p be -1 and q be 3. Good. So this equation, maybe let's call this star, all right? I didn't give this a name beforehand. So star becomes what? We're going to put each of those into star and check. So p is -1, so we're going to have -1 plus q is +3. You're going to have 3, sorry. Q is +3, so we're going to have 3i, all right? And then we're going to square this to see what we get. Are we going to get the left hand side after squaring that, given that p is -1 and q is 3? So let's square this and see. Well, we square 1, we square -1, we get 1. Then we square 3i, we're going to get -9, right? -9. Well, the next part will give us -6i. This is -8, which is not equal to +8. So in fact, this will not give us what we want, all right? Good. So let's check for when, let's switch, like let's interchange. Let p be 3 and then q be -1. Good. So for each of these selections, we are going to interchange, because remember I said p and q are arbitrary. Good. So when p is 3 and then q is -1, what happens? Okay, so star becomes, we're going to have, in place of p, we're going to put in 3. We add it with, in place of q, we're going to put in -1. But that is -i. So let's just put the negative there. And then you put the I. Good. Then we square this. Let's see if you're going to get 8 minus 6i. So when we square 3, we're going to get 9. when we square negative 1, all right, negative 1, I will get negative 1. And that is built into the fact that, well, negative 1 will be positive 1, but I squared is negative 1. So that gives us a negative 1 as a result. And then we're going to multiply these terms together. 2 times 3 times negative 1, that will be negative 6i. Good. 2 times 3 times negative I meant to say. Good. So this is going to be, well, this makes sense. 8 minus 6i. And that's exactly what we want, right? So this right here works. So we can say this right here works. Good. So if P is 3 and Q is negative 1, we get a solution, all right? Yeah. But could we have other maybe solutions? Of course, not really other solutions. We can have one more solution, and that is when, let's see, when we negate the solution here. So let me just show you what I mean. So that this equation will become, or this will become, this complex number will now become, given that P is 3 and then Q is negative 1. That will be negative I. So you say 3 minus I, right? This will satisfy that. But if we take the negative of this, it will also satisfy that. We can also say, or P plus QI can also be negative of this, which is negative 3 plus I. Why is that so? Well, this is a square. We need to square this to get that. Whether this is a negative of itself or just like this, if you square, you still get the same result because it is square that we are talking about here, all right? I'm not saying we square, you get the same non-negative number, but we'll get the same result. These are complex. So it's either this is positive and this is negative, or this is negative and this is positive. The result stays the same. And in fact, we can put the result in a better form by saying that this is positive or negative. This is 3 minus I, just like we had before, all right? So I'm going to equate these two. Well, positive or negative, okay, we're going to have 3 minus I. Good. And then we can square that, so that when we take the square root, we get the solution. And that's good, okay? So, but like I said, the limitation of this trick is that if P and Q, if there are no integers, so that when we multiply, so that P and Q satisfy this equation, then you have to use the method we used to do for the first one, because the method may not be helpful, right? Okay, thanks for watching. Please share this video with your friends, and in the next video we're going to see how we can represent a complex number on a plane, and then from there we'll get into a lot of interesting stuff. Okay, thank you for watching.